Hey guys, welcome to Unit 16. So we only have this unit, transformation of graphs, and then one other unit, dividing polynomials, and we're done with Algebra 1. You finished Algebra 1 after this. So give yourself a pat on the back, you're almost there. Super proud of y'all. I wish we could finish this up together in class, but that's okay. I'm glad I still get to teach y'all through technology. That's kind of cool. But anyway, transformation of graphs. So we kind of touched on this a little bit in the first semester when we talked about linear functions. And we talked about how we could shift, move up and down, left and right, a linear graph, a line. We talked about how we could make it steeper or less steep. And that's true. We can do all that with linear. But now we've talked about so many other graphs. We've talked about quadratics, and we just got done talking about exponential functions. So now we've got linear functions, quadratic functions, and exponential functions. And guess what? You can transform all of the graphs. You can move up and down a parabola. You can move up and down an exponential function. And it's done by shifting the graph. So this word here, shift, again, this is a review because we did it with linear, but the word shift, all it means is we're moving it. Move it. We are moving the graph. We're sliding it up, down, right, left. So again, we can move graphs left. We can move them to the right. We can move them up, and we can move them down. So those are the 4 types of shifts that we can have. If we look at which way a graph moves, they gave us this function, g of x equals f, parentheses, x minus c plus d. Now, because this in the formula has minus c, well, what's really happening is if it's inside the parentheses, it's the opposite. So just like we've done it before when we have formulas that have a minus, when you take it out, it's really a plus, right? So if you're looking inside the parentheses, if we're looking at this part here inside the parentheses, this C, and this sign along with the C, tells us to move it to the right or the left. So if I move it to the left, it's going to have a plus sign. And again, it's opposite because when I pull it out, it's really subtracting. Or I can move it to the right, which is going to have a negative sign. And again, I know you're thinking it's opposite, like positive should be moving in the positive direction and negative should be moving in the negative direction. But again, this sign here, this negative sign or minus sign, changes it, so it's the opposite. So if you have your function plus a number, you're really going to the left, because you're really taking minus a negative. If you have minus, it's really a plus. Now, this plus D moves it up or down. So you move it up, whoops. You move it up if it's positive, and again, this is because there's not a minus sign here, it's a plus, or you can move it down, which is negative. So you're just looking at these signs. And that's literally all there is to it, to moving graphs up and down for any kind of function, quadratic, linear, exponential. So let's try some examples and see if we can get the hang of it. It says, describe the transformations represented in each of the equations below. So let's look here. So I've got this plus 7. So inside the parentheses, that tells me to either move left or right. And outside the parentheses tells me to either move up or down. Inside, left, right, outside, up, and down. And for inside, we discussed if it's a positive, we're really going to the left. It's opposite. So we're going to the left 7. And then if it's negative, we're going down. So we're going down 5. So this graph is shifting to the left 7 and down 5. Let's look at number next. Okay, again, inside tells me left or right. I do the opposite of what it tells me, so since it's negative, I'm going to the right. So I'm going to the right 4. And then I'm going either up or down. Well, it's a positive, so I'm going up and 1. That's a 1. So those were all linear because there was no x's as an exponent for exponential or x squared for quadratics. So these were linear examples. But look at this one. Now I've got an x squared. So I'm taking my x and I'm squaring it. So these are going to be quadratics. So I'm taking a parabola and I'm moving it. I'm going to do the same thing though. I have minus 8, which tells me I do the opposite. So I'm going to the right 8. And then I have plus 3. I'm going up 3. So it's the same as linear, just that 2 tells me it's a parabola. Let's look at this one. Plus 1, I do the opposite, so I'm going to the left 1. Plus 3, I go up 3. Not bad, right? Minus 4, I do the opposite. So I'm going to the right 4. Minus 10, I'm going down 10. Okay, number last. Inside I've got plus 6, I do the opposite. So I go to the left 6. Now if you notice, there's no plus b here. Technically it's plus 0. So I'm not going up or down any. I would be going, if I read this like this, I would be going up 0. I'm not moving at all. So all that's happening to this graph is I'm going up 6. And it's possible to have it the other way. You could just have x, nothing in the inside, and a plus or minus b on the outside, and you would just be moving it up and down. Okay, so that's all there is to shifts. You're just looking inside the parentheses, tells you left or right, and you take the opposite. If it's positive, you move to the left. Negative, you move to the right. Outside the parentheses is what tells you to move it up or down. If it's positive, you're going up. If it's negative, you're going down. So that's 16.1. That is shifts of graphs. That's it. There's other transformations that you can do with graphs, and we're going to get into that in the other lessons of 16. There's vertical stretches and compressions, there's horizontal stretches and compressions, and then 16.4 we're putting everything together. So 16.1 is just moving left, right, up, and down. That's it. Look, y'all, I made it under 10 minutes. Y'all should be proud. Okay, tell your classmates to watch my videos. I work hard on these. I love teaching y'all. Watch my videos. This one's short and sweet. Bye, y'all. Have a good day.